last video we discussed the definition of a function. Okay, so given two A and B non-empty set, a function from A to B is a rule of correspondence that assign to each element in set A exactly one element in set B. So there we observe that each element having a assignment to each element is important, and each element going to exactly one element is also important to determine whether a rule is not a function, whether a rule is a function or not, deciding. Okay, so this set A is called the domain and B is called the codomain. Also we observe the importance of the domain and the codomain. We realize that same rule can give a function or it may not be a function depending on the choice of A and B. Okay, also we discuss about the range of a function. Okay, here we will look at some examples. So if you take a group of people at random, we will notice there is a connection between their ages and height. Okay, so because people get taller with time. Okay, so according to age, their height may change. Okay, also they might remain at the same height for a while. Okay, so if you look at this connection, it's not a function. Okay, because if you look at a specific age, there can be different people at that age with different heights. Okay, so if we look at here, if we look at the ages of various individuals in a set and heights of those various people in another set, we might have some age, two people of age 22 might have different heights, no? So for example, if we consider this batch, there are people with the same age but different heights, no? So one age may get related to several heights, so it may look like this, so it may not be a, it's not a function, no? But if we take the height of a particular person over the years, the height will be a function of age, no? If we look at the same person, because this person will have only one value of height at any point in life. Okay, so if we look at the ages list of if we look at the list of records of age of one individual, no? Okay, this says age of one individual and there is the height. So each time of point for each age there will be only one height. So but he might have two ages with same height, no? Because he might remain at the same height for a while. For example, from maybe from 25 or 26 person might not grow taller, so they might have the same height at 25 and 26, no? So same height for two ages, but this is a function as we observed, no? So if we consider one person, height is a function of age of that person, no? Also if we look at a college, students take different classes to fulfill the requirements of a given course. If students may have different grades for different subjects, no? So there is a connection between the students and their grades. Again, this is not a function because we might have, if we consider the set of names of the students and grades, I might have one student, he might have two different grades for different subjects, no? So here I have the student, one student might have two grades, they might get maybe a B for calculus and C for physics likewise, or other way around, C for calculus and B for physics or something like that. So one person might have two arrows going out, he might have two grades for different subjects. So in this situation it's not a function. But if we look at a single class, we will assign each student a grade depending on the performance of that particular subject. Then student cannot have two grades for the same subject, no? So because of that, each student will have exactly one grade. Okay, and if we assume no absences, each student will receive a grade. So if we assume that no advances, if these are the different names of the students in the calculus class, and if this is the grade for calculus, if we assume that there are no absences, each student will have one grade, no? So this is again a function. Okay, so here we look at some examples of functions. Okay, so in the next video we will look at ways to represent functions. Okay, different. We already saw one way to represent function using pictures. Next one we will look at different ways to represent functions. Okay.